In this video, let us analyze the different properties of the measurement for linear association, which is our correlation coefficient. The properties of correlation coefficient are: number one, it makes no distinction between explanatory and response variable. That means it does not change the value when we change the units of measurement for x and y, or both. This has no unit of measurement because it is just a number, and the value of r lies between -1 and +1. If r is positive, then it says that the two variables x and y are positively associated. If the value of r is closer to negative, then it means they are negatively associated. If the value of r is closer to 0, then it indicates it has very weak linear relationship. Let's take an example. Since it is hard to measure the overall height of elderly people because they cannot stand straight, they usually measure the knee height to predict the overall height of a person. A study is made and they have calculated the height to the knee, and the height to the knee is used to find the overall height. So we can find the relationship between the two variables x and y, where x is our explanatory variable knee height, y is the response variable, that's what we are trying to predict, that is our overall height, and here is the data. The data for 5 elderly men are given. Let's make use of this example to discuss the different properties of our correlation coefficient. We have the two sets of values x1, which is our explanatory variable, y1 is our response variable. We are trying to find the relationship between the two variables for which the scatter plot is given here. We would like to get a regression line of x1 and y1. So let us take y1, which is approximately equivalent because the line will not pass through all the points, mx1 plus b. And that is the regression line, what we see here on the screen for the scatter plot what we have. The regression line is y equals 2.42535 x1 plus b 44.1315. And for this line, we have the coefficient as 0.77, which is pretty good because these points are close to the line and it has a strong relationship. And the value what we find here, E1, is the residue. And the residue is nothing but the difference between the y value and the y hat value, the regression line values. If you change the values y1 and y2, x1, you must get the same correlation coefficient according to the property. If we change the units of y1 and x1 also, we should get the same coefficient. So we have got two values x1 and y1 which are interchanged now. x1 is our knee height, overall height, and y1 is our knee height. We got the equation y, and the coefficient r is 0.877, which is the same as our previous case. So when we change the values x1 and y1, the value of r is not altered. So here we have changed the value for x in terms of millimeters, y in terms of meters. And for these two, we got a totally different regression line with a different slope and a different intercept. But the correlation coefficient is the same. So in this case, even if we interchange the values, the correlation doesn't change. Even if we change the units, the correlation doesn't change. So we saw all the different properties of the coefficient. And we also know that the coefficient r lies between -1 and +1. And if it is closer to +1 or -1, then it has a strong relationship. If it comes closer to 0, then it has a weak or no relationship here. Thank you for listening. Thank you for watching my video.